Hello, ladies and gentlemen. Welcome back to our study on probabilities. So now we're going to be doing skill 1.2, which is on two-way tables. So rather than subjecting to my notorious handwriting, these are some important ideas about probabilities that you should have copied down. So you may want to pause the video here and kind of write down these ideas. The first idea is the idea of a mutually exclusive event. So an event could be, a trait of somebody, like maybe we have a junior in high school, somebody's a junior and somebody's a senior. We can't have a junior and a senior at the same time. Another resource that we have here that is going to come really in handy, and I'm going to put a box around this for the importance, is that the OR probabilities are, technically speaking, the probability of A plus the probability of B minus the probability that both occur. So if events A and B are mutually exclusive, then the probability of A and B is 0. So that's why I put a star in scale 1.1. And then the conditional probability, this is where, we say, what's the probability of A given that B has occurred. So we're actually going to see some examples about how we cover up sections of the two-way table. So we have two-way tables to actually better visualize these sorts of problems. Okay, let's look at an example here. So we have a class of 25 students and 15 are female and 16 have an A in the class. There are 12 students who are female who have an A in the class and have an A in the class at the same time. What is the probability that a student has an A given that a student is a female? So this is just basically asking, in other words, what is the probability that a female, so we're restricting our population to females, has an A. So when we are setting this problem up, we are looking at the number of female A students over the number of females. So it's as if the males are not as important. So fortunately, we have 12. It says that 12 students are female and have an A. So that's one piece of information. So that's B. And then we have the number of females. So we have 15 are female. So we do 12 over 15, and that's equal to 0.8. So that means that 80% of the females have an A in the class. So with this situation, you could kind of just restrict to females and just set up the fraction. But fortunately, we have a tool here where you can actually draw tables. So this is the probability given of something. So you have an Algebra 2 class here, and we have 2 sports. So these are two-way tables. So we're looking at who plays basketball and who does not play basketball. And there are 12 students who play neither sport. What is the probability that a student chosen at random plays both baseball and basketball? So I think what the best thing to do is to draw a table like this, where you're looking at the total number of people and who playing baseball and who's not playing baseball. And we have 30 students in total. So that's the total. We have 8 students that play baseball. And we have 12 students that do not play either sport. So this is does not play and does not play. And 16 that play basketball. Just do that in pink. So you can kind of see where the numbers kind of lie in our table. And it's asking us, what is the probability that a student chosen randomly from the class plays both basketball and baseball? So we want both. So it's chosen randomly from the class. And you could kind of like, you want all the rows to add up to the end, and you want the columns to add up to the end. So I'm just going to look for what has like kind of one missing piece. So if we have 8 people that play baseball, that means that 30 minus 8 do not play baseball. And we want the 12 and 10 to add up to 22. And we want 6 and 10 to add up to 16. And then does not play baseball, that would just be 2. So I like to kind of like fill in those numbers. So we're looking at playing both. So that's going to be 6 out of 30, which simplifies to 0.2. All right, and then this one is our first conditional, kind of conditional type of probability. Actually, not yet. We'll get to that a little bit later. But this is just kind of getting familiar with the two-way table. So in a class of students, this looks at how many students have a brother or a sister. What is the probability that a student chosen randomly from the class does not have a brother? So we do not care. So we care about like the number of students in the class. So I might want to see, what the totals are. So we have 10 people that have a sister. We have 18 that do not have a sister, for 28 in total. And we can kind of see the total on the bottoms as well. And they should add up to the same. And we do not care about having a brother. So we are looking at only does not have a brother. So we're actually just going to black out, literally black out this section. And it says, what is the probability that a student chosen at randomly from the class does not have a brother? So it doesn't matter if they have a sister or not. So we are going to do probability of not having a brother. So number without a brother over total in class. And that is going to be equal to 23 over 28. That's going to be about 0.821. All right, so just make sure you are, if you finished early, start taking a peek at the Delta math practice, but we will be coming back together soon for a peer deck check-in time.